أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم السلام عليكم ورحمة الله وبركاته. This is SS3 online class. You are welcome to this edition of the online class. Just like I've informed you earlier, we are going to start with the solution to the mock examination. Solution to the mock examination. Having gone through your scripts, I discovered that there are some areas that need more emphasis, and therefore we are going to look at those areas today. Inshallah, we are going to look at the solution to all questions, but there's need for emphasis. We are going to lay such emphasis. So you are welcome. Question 1. The first question asks you to define OR. What is an OR? From many of the definitions that I saw in your solutions, I knew that you need to be more enlightened. Definition of an OR should state that it is a naturally occurring solid substance. It should be involved in your definition. Number 2, it should also include that it contains a metal in relatively high proportion so that the metal can be extracted from it. So once your definition contains these key points, it's okay. A naturally occurring solid substance that contains a metal in relatively high proportion such that the metal can be extracted from it will get you a full mark. I hope that is taken. Please. Then question 1A2, you are asked to state the main ORs of each of the following. See, now look at the word main, because some of the metals have many ORs, but the question is the main ORs of each of them from which the metal can be extracted. So the main OR of tin is cassiterite. Or simply tin stone. The main ore of iron is amatite, and not iron pyrite or magnetite, as some of you stated. Though those are also ores of iron, but they are not the main ore from which is extracted. And the main ore of aluminium is bauxite. So please take note of that. The next one is definition of nucleons. Many of you performed well on this question, but there are some people that defined nuclides rather than nucleon. Nucleons are the subatomic particles that are present in the nucleus of an atom. You state that you are correct. You can as well define nucleons as protons and neutrons that are present in the nucleus of an atom. In that case, you are being more specific. So the protons and neutrons found in the nucleus of an atom are called nucleons. Radioactivity. Radio from the word radiation. And this is defined as the spontaneous emission of radiation by a radioactive element, which usually accompanies disintegration of the radioactive element. Spontaneous emission of radiation that accompanies nuclear disintegration. Spontaneous emission of radiation that usually accompanies nuclear disintegration or disintegration of a radioactive element. Half-life. Many of you performed well on this question, but we still have some people that do not perform well. The half-life of an element is half the time taken for half of a radioisotope to completely disintegrate. Time taken for half of a radioisotope to completely disintegrate. Then you have nuclear fission. Fission means splitting or breaking into pieces. So we would therefore define nuclear fission as the process by which a heavy nucleus splits into two smaller nuclei of similar or comparable masses. Splitting of a heavy nucleus to two smaller nuclei. Nuclei is the plural of nucleus of comparable mass. Comparable mass means that their masses are similar. Then you have nuclear fission, which is the nuclear fusion, which is the opposite of nuclear fission. So your definition must contain emission of radiation and energy. Also nuclear fusion. Nuclear fusion means the process by which two smaller nuclei join together to form a larger nucleus with the emission of radiation and high amounts of energy. So instead of, it is the direct opposite of nuclear fission. It's the direct opposite of nuclear fission. The process by which two smaller nuclei come together to form a heavier nucleus with the emission of radiation and energy. The reaction that takes place in the sun is actually a fusion reaction, and that is where the bulk of the energy that is required on the earth is generated. Now coming to question 1C, where we have some of you not doing very well. You have this structure and you are asked to name this compound. Unfortunately, many of you could not name the compound correctly. If you look at this structure, you would see 1, 2, 3, 4, 5, 6. You have 6 carbon atoms. Hydrogen atoms 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Each 12. I have 1, 2, 3, 4, 5, 6. 6. But looking at the functional group that is present, you see that this is an aldehyde group, an alkana group. And that shows that this compound is an aldose. And that means it is glucose. You know, if it is a ketose, if it contains a ketone group, that is a ketone group or an alkanone group, it will be fructose. So this is glucose. So the name of the compound is glucose. Simple as that. This is not a normal hydrocarbon or an alkanol. I received so many funny answers. Now you are asked to name 2 functional groups presently. You can see this is a functional group, this is a carbonyl group, and this is another functional group that you have as many as like 5 of them there. So the first functional group here is the carbonyl group, That is. Or if you want to be more specific, you can call it an aldehyde group. And for this, for the other group here, is what? It is hydroxy group. Hydroxy group. So those are the two functional groups present in the structure. So easy. Then you have to name a polymer of the compound that is of plant origin. A polymer of the compound that is of plant origin. So you have many polymers of glucose, and most of them are of plant origin. You have cellulose, you have starch, you have phenolene. So just mention any one of them. Cellulose will be an appropriate answer. If you mention starch, you are also correct. You are asked to show with an equation how the compound reacts with hot concentrated tetraoxosulfate 6 acid. I have told you hot concentrated tetraoxosulfate 6 acid would not react as an acid, rather it will react as a dehydrating agent. You know, tetraoxosulfate 6 acid has many parts. It's an acid, it's a dehydrating agent, it's a drying agent, it's an oxidizing agent. But when it is hot and concentrated, it mostly reacts as a dehydrating agent. So in this case, whenever hot concentrated tetraoxosulfate 6 acid comes in contact with a sugar, it will dehydrate the sugar. Now C6H12O6 with the presence of hot concentrated tetraoxosulfate 6 acid. If you like, I can put it on top of the arrow. If you can like, I can put it as a reactant. It will give us, let's put it on top of the arrow. That is more appropriate. So what will happen there when dehydration is taking place? Water molecule is removed from the compound, and that means you have 6H2O being removed, minus 6H2O. Because we have 6 molecules of water here. Then it will remain only 6. So this will be in solid form, and solid form as well. So this is the equation that is required of you. Now, coming to the next question, and that is question 1D. The question reads 25.0 cm cube of a sample of water produced ladder on addition of 33.0 cm cube of a saturated soap solution. Another 25 cm cube of the water that has been boiled requires 15.0 cm cube of the soap solution. If 25 cm cube of the distilled water require 3.0 cm cube of the soap solution to produce ladder, calculate the ratio of temporary hardness to permanent hardness. Now, there are 3 stages in the question. First, soap solution was added to the raw sample of water, and we got the amount, the volume of soap solution required. Volume of soap required for water, ordinary water, is 33.0 cm cube. Volume of soap required for boiled water is equal to 15.0 cm cube. Now, between the raw water and boiled water, something has happened. When water is boiled, we all know that temporary hardness will be removed. So it shows that the degree of temporary hardness in the water sample is the volume of soap required for the raw water minus volume of soap required for the boiled water, and that will give us 18.0 cm3. That is 33.0 minus 15.0. Now, next step is that the same water was distilled. The same water was distilled. And when the water was distilled, it was discovered that only 30 cm3 of soap solution is required to start to form ladder. So we now have volume of soap required for distilled water. It is equal to 30.0 cm3. Compare this to volume of soap required for boiled water, which is 15.0 cm3. So the degree of permanent hardness is the difference between volume of soap required for distilled water and volume of soap required for boiled water, and that will give us 15 minus 3. That will give us 12.0 cm3. So you are now required to calculate the ratio of temporary hardness to permanent hardness. Temporary hardness is 18.0 cm3. That is the degree. Permanent hardness, the degree of permanent hardness is 12.0 cm3. Therefore, ratio of temporary hardness to permanent hardness will be equal to 18 ratio 12, and that will give us 3 ratio 2. That will take us to the end of the question. I hope it is clear. Please quick, you can go over the solution again to make it clearer. So question 1E, you are asked to define entropy. Entropy is the degree of disorderliness of a system. The degree of randomness or disorderliness of a system is called entropy. When you have a solid system, the particles are closely packed together. Therefore, the particles are orderly. But when it becomes a liquid, the particles are loose, and so the degree of disorderliness increases. When you have the substance becoming gas, the particles are free. The particles continue to move in random motion. Therefore, they are in disorder. So when a solid substance changes to a liquid, the entropy increases. When a liquid becomes a gas, the entropy also increases. So change in entropy from solid to liquid is positive. Change in entropy from liquid to gas is also positive. Change in entropy from solid to gas is positive. The converse is negative. That is, change in entropy of a gas becoming a liquid is negative. If a liquid becomes a solid, the change in entropy is negative. And if a gas becomes a solid, the change in entropy is also negative. Now you now have an equation. Okay, so you now have an equation. That is question 1E, 1E2. You have an equation where you have a solid substance forming another solid and a gas. Here it is entirely solid. Here you have a solid and a gas. So the disorderliness of the product is more than the disorderliness of the reactant. Therefore, entropy has increased, and that means change in entropy is positive. So the answer here is you just write change in delta S is positive. Or delta S is positive. That will be your answer.
Remember to change your slippers.
Now, question 1E3. Okay. Question 1E3. You are required to arrange the following increasing order of rates of diffusion. Increasing order of rates of diffusion. We all agree that rate of diffusion depends on the relative density. The more the relative density, the less the rate of diffusion. Even if you remember Graham's law of diffusion. Rate of diffusion is inversely proportional to the square root of the vapor density or relative density. Therefore, when you are, and we all know that relative density is half of the molecular mass. So when you are given this type of question, what you just need to do is to find the molar mass of the substances involved. The one that has the lowest molar mass will be the one that will diffuse fastest. The one that has the highest molar mass will be the one that will diffuse slowest. So, from the information given, the molar mass of ammonia is 14 plus 30, that is 17. The molar mass of this one is this is methane. The molar mass of this one is 16. The molar mass of this one is 36.5, and the molar mass of this one will be 32 plus 2, that is 34. In that situation, the question says increasing order of rate of diffusion. It means you have to start from the slowest diffusing to the fastest diffusing. So when you are dealing with increasing rate of diffusion, it means you have to start with the highest molecular mass. Because the higher the molecular mass, the lower the rate of diffusion. So what the question is telling you, start from the highest molecular mass and end with the lowest molecular mass. And that will give you hydrogen chloride first, diffusing slower than hydrogen sulfide, diffusing slower than ammonia, diffusing slower than methane. So this shows the increasing order of rate of diffusion. And that takes us to the end of question 1 in your mock examination. I pray that Allah grants all of us better understanding and bless our knowledge. Before we end the class, you have to check your portal to assess the assignments given and solve the questions. You receive your mark almost immediately. Assalamu alaikum wa rahmatullahi wa barakatuh. When we meet next class, we are going to continue with the lesson, and that is with question 2.